900 meters below the surface of the North Atlantic, a hydrophone attached to an offshore drilling platform recorded 14 minutes and 31 seconds of audio that, 2 years later, nobody has been able to explain. The recording exists. Engineers have confirmed its timestamp and the equipment that captured it. What's on it has been analyzed by marine biologists, signal processing specialists, and, quietly, by at least one team with a background in underwater acoustic intelligence. None of them agree on what produced the sound, but several of them, on and off the record, have used a word that scientists are trained not to use lightly. Intelligent, not alive, not biological, not animal. Intelligent, in the specific sense of conveying structured, non-random information that doesn't match any known natural source. Before we go further, a caveat that matters. The word intelligent in acoustics has a technical meaning that isn't the same as the popular one. A signal can be called intelligent when its informational structure exceeds what noise or simple biological processes typically produce. That doesn't automatically imply a conscious mind. It could point to a complex machine, an unusual atmospheric or geological event, or a cognitive source we haven't identified. What it does mean is that the sound has structure the listener's tools can measure, and that the structure is hard to reconcile with the environment where the sound was captured. This particular recording was made in late 2023 from a platform in the Faroe-Shetland Channel, a stretch of water between Scotland and the Faroe Islands where the North Atlantic spills southward over a submarine ridge. The depth profile is complex. Warm surface water flows north, cold, deep water flows south, and the interaction creates acoustic conditions that can carry sound over enormous distances. The platform itself was conducting standard environmental monitoring, which includes continuous hydrophone recording to track marine mammal presence and flag any sounds that might indicate sensitive behavior in the area. The log entry for the night in question is short: hydrophone array active. Routine background noise. At 02:17 local time, an unusual signal appeared. It was loud enough to register across all 8 sensors in the platform's perimeter array. The technician on duty flagged it for later review, which is standard procedure. Later review turned into a problem. The first analyst assigned to the recording assumed it would turn out to be a whale. The frequency range was consistent with large cetaceans, broadly speaking, and the Faroe-Shetland Channel is home to fin whales, sperm whales, and occasional blue whales passing through on migration. But the pattern didn't match. Whale vocalizations have been cataloged in obsessive detail over the past 50 years. Every population has its own song variants. Every species has its signature calls. The recording didn't match any of them. The analyst sent it to a marine biologist at the University of St. Andrews, which hosts one of the best bioacoustics labs in the world. The biologist ran the recording through the standard identification pipeline. The pipeline returned no matches. She sent the file to colleagues in Norway and Iceland. No matches there either. Someone suggested it might be a pod of killer whales performing an unusual behavior. The waveform didn't support it. Someone else proposed a malfunctioning submarine. The spectral profile didn't match any known engine signature, and the submarine proposal quietly faded. The recording began to circulate in smaller circles. Within a few months, it had been heard by perhaps 50 specialists in various subdisciplines of underwater acoustics. No one had a confident identification. What emerged from the informal consensus was a list of what the sound was not. It was not a whale. It was not a submarine. It was not a pipeline stressor, a seismic pulse, or a fish chorus. It was not, as far as anyone could tell, the result of any equipment artifact on the platform itself, because engineers had gone back through the maintenance logs and verified that nothing unusual was happening at 02:17 that night. Then, someone ran the audio through an information theoretic analysis, and that's when the conversation shifted. Information theory gives you tools to measure how much structured content is present in a signal. A tone is low in information. White noise is Also low, paradoxically, because randomness is easy to describe. Signals that are high in information sit between these extremes. They have patterns, but the patterns are complex and not easily predicted. Human speech is high in information. Music is high in information. Whale song, surprisingly, is moderate, because it repeats frequently with variations. The hydrophone recording from the Faroe Shetland platform registered higher on several information-theoretic measures than any naturally occurring underwater signal the analysis team had previously examined. That finding was striking enough that the team who ran the analysis asked for the recording to be shared with specialists at an intelligent signal analysis group. What happened next is where the story gets murky. The specialists did review the recording, and they returned the review with a short written summary that said, essentially, that the signal did not match any known artificial source in their catalog, and that the structure was not incompatible with intentional communication, but that no specific claim of intentionality was being made. That language, cautious as it is, caused the recording to be pulled from informal circulation and placed under a tighter distribution restriction. Eventually, a sanitized summary of the findings was shared publicly. The full recording has not been released, although multiple specialists have confirmed its existence and general features. So, what does the sound actually consist of? The description that's been made public describes a complex signal with three main components: a low-frequency carrier tone, modulated in slow patterns, a set of mid-frequency pulses that appear at irregular but non-random intervals, and a high-frequency fringe that seems to sit just at the edge of the hydrophone's sensitivity range, suggesting the actual sound may have extended higher than the equipment could capture. The mid-frequency pulses are the component that generated most of the analysis discussion. They don't repeat in a predictable cycle. They vary in a way that, when plotted, produces a distribution that matches what you'd expect from encoded messages rather than from periodic natural signals. Taken together, the signal sounds, according to those who have heard it, neither like a voice nor like a whistle. It has been described as oscillating, layered, and unsettling to listen to at length. One researcher said it reminded her of the feeling of hearing an unknown foreign language, that you can tell is a language but cannot parse. Several explanations have been proposed. Each has weaknesses, and that's part of why the mystery has held. The first is a biological source we haven't cataloged. There are deep-sea species we still know very little about. Beaked whales, in particular, were barely understood acoustically until recent decades, and some of their vocalizations would sound strange to a casual listener. It's possible the recording captured a rare species producing an unusual call. The problem is that beaked whales and other deep-diving cetaceans have been studied enough that the broad acoustic envelope of their communication is known, and the Faroe Shetland signal falls outside that envelope. It's not impossible, just unlikely. The second is a geological source. The ocean floor is noisier than people realize. Volcanic activity, gas venting, methane hydrate release, and tectonic stress can all produce sounds. The Faroe Shetland channel has geological complexity, and the recording was not made during any known seismic event, but unusual subsurface processes are possible. The challenge here is the information structure. Geological sounds tend to be broadband and irregular in a characteristic way. They don't typically produce the kind of layered, structured output described in the recording. The third is an artificial source we haven't identified. Other vessels, underwater infrastructure, experimental equipment, or platforms operated by parties that don't publish their activities. This is the most mundane of the candidate explanations, and probably the most likely. Oceans contain a lot of machinery that civilians don't know about. The problem is that specialists who know that machinery well have reportedly examined the recording and haven't identified it, which narrows but doesn't eliminate this possibility. The fourth is the one people want to talk about, and it's the one that gets the cautious language from specialists. A source we don't have a category for at all. Something producing a structured signal that doesn't fit human, animal, or geological origins. The scientific default is always to prefer the mundane explanation until the mundane runs out. For many specialists, the mundane hasn't run out. For a smaller number, it has. Dr. Linnea Carlson, a hydroacoustics researcher at the Norwegian Institute of Marine Research, has been one of the more cautious voices in the discussion. She has argued that the mystery status of the recording is overstated. She points out that the ocean is acoustically chaotic, that unusual-sounding signals are captured routinely, and that the fact that 50 specialists couldn't identify something doesn't mean nobody ever will. Catalogs of underwater sound are incomplete. Rare events happen. Given enough hydrophones and enough time, some of those events will sound strange. She urges patience and further data collection, not leaps to unusual explanations. Her view is probably the correct default. But she has also acknowledged that this particular recording is among the harder cases she's encountered, and that she would welcome public release of the full file for broader analysis. That public release has not happened. The reasons for it are partly bureaucratic, partly the involvement of a defense-adjacent analysis group, and partly the understandable caution of the platform operator who doesn't want the recording associated with speculation that could affect its operations. Those are not sinister reasons, but they do mean the mystery is being preserved longer than it might otherwise be. In the meantime, other hydrophones in the north, Atlantic, have been set to search for similar signals. Several candidate matches have been flagged, none confirmed. If a second, independent recording of the same acoustic signature emerges, the conversation will move quickly. A single anomaly can be dismissed as a fluke. A repeated anomaly becomes a phenomenon. Broader context may help. Ocean acoustics has produced famous mystery sounds before. The so-called bloop, recorded by NOAA in 1997, was eventually attributed to ice calving in Antarctica. The upsweep, another NOAA recording from 1991, has been tentatively linked to volcanic activity in the Pacific. Julia, Slow Down, Train, and other cataloged mystery signals have gradually been assigned natural explanations as more data accumulated. Every time, the process took years. That pattern is probably reassuring. Most mysteries resolve. What starts out as unexplained usually ends up as understood, given enough time and enough instruments. But the pattern also contains a warning. Some of those earlier mystery sounds held out for more than a decade before they were explained. During those years, they were genuinely anomalous, and the fact that they were eventually resolved doesn't mean they should have been dismissed from the beginning. Taking anomalies seriously, even when they turn out to have ordinary explanations, is how acoustic science advances. The Faroe Shetland recording deserves the same patient treatment. Whatever produced the sound, one thing is beyond dispute. A hydrophone on an active industrial platform captured 14 minutes and 31 seconds of audio that specialists across multiple institutions have been unable to identify. The recording is real. The confusion is real. The structured complexity of the signal, by information-theoretic measures, is real. The most likely answer is that someday, maybe soon, a researcher will figure it out and the mystery will collapse. Maybe a rare beaked whale variant, maybe a newly noticed geological process, maybe a piece of equipment whose existence wasn't publicly documented but becomes known later. Somewhere, almost certainly, the explanation exists. But until that day arrives, the recording sits in a limited access archive, and the ocean keeps producing sounds nobody was meant to hear. Most of those sounds are whales or waves or the slow groan of the planet adjusting under pressure. One of them, captured on a quiet night in 2023, still hasn't been named. That feels worth sitting with. Not because the answer is necessarily extraordinary, but because the question, for now, remains open. And in a world where most questions get answered within days, the ones that hold out for years or decades tend to be the ones that eventually teach us the most. The hydrophone is still running. The analysis continues. Whatever is down there, or was down there, has gone quiet again. But the silence after a signal like that is different from the silence before it. You can hear the difference if you listen hard enough. And somewhere in the next stretch of tape, the answer may be waiting to speak again. It helps to remember how thoroughly humans have filled the ocean with sound that wasn't there a century ago. Container ships, sonar pings, seismic air guns, offshore drilling, underwater communications. The modern sea is louder than at any point in its history, and most of that noise is ours. Marine biologists now speak of acoustic pollution as a serious stressor for whales, dolphins, and other sound-dependent species. Some populations have altered their vocal ranges to avoid overlap with shipping noise. Against that backdrop, picking out an anomalous signal is a bit like trying to pick out a whisper at a rock concert. The fact that the Faroe Shetland recording stood out at all, clearly enough to catch the attention of routine monitoring software, means it had a quality distinct from the soup of man-made noise surrounding it. That distinctness matters. If the signal were simply another vessel or another drill, it would have been identified immediately. The existing catalogs of industrial sound are detailed enough that familiar sources rarely cause confusion. What causes confusion is something that fits none of the categories. And that's what the specialists who reviewed this recording have been reporting. There's another angle worth exploring. In recent years, researchers have become more comfortable describing certain animal cognition findings with the language of intelligence. Sperm whales appear to have regional dialects with structural complexity that some linguists have compared, cautiously, to proto-languages. Humpback whale songs evolve across populations in ways that resemble cultural transmission. Elephants respond to recordings of deceased family members with behaviors that look like mourning. Octopuses coordinate color changes in ways that may encode information even though they're colorblind. The animal world is full of structured communication we didn't understand a generation ago and are only now learning to take seriously. Whatever produced the Faroe Shetland signal, it's worth considering that our catalog of what marine life is capable of is incomplete. The signal may eventually be attributed to a species or behavior we haven't described yet. That would not be paranormal. It would just be new. The ocean covers roughly 70% of the planet and remains, by most measures, less well-mapped than the surface of the moon. There's plenty of room for the living creatures that swim through it to surprise us. At the same time, we shouldn't lean too hard on the biological hypothesis just because it's safer. One of the reasons specialists have struggled with this particular recording is that it doesn't carry the signatures that biological signals usually carry. Animal vocalizations, no matter how complex, tend to sit within characteristic frequency envelopes, have recognizable onset and decay patterns, and relate to the physiology of the producer. The hydrophone signal reportedly lacks some of those features. It doesn't quite sound like a throat, a chamber, or a body producing sound. Several reviewers described it as feeling, for lack of a better word, mechanical, without being matchable to any known machine. That's the uncomfortable middle ground the recording occupies. Not clearly alive, not clearly built, not obviously geological, not obviously a recording artifact. Every explanation has to explain away one or more features of the signal, and none of them explain it cleanly. One final consideration. The Faroe Shetland Channel sits over what geologists call the Iceland-Faroes Ridge, a region where unusual volcanic and hydrothermal processes occur at depth. Methane hydrates are known to destabilize in this area under certain conditions. Large releases of gas passing through overlying sediment and water can produce sustained acoustic signatures that mimic some of what's been described in the recording. A team studying methane venting in the region has offered this explanation as a candidate, though they acknowledge it doesn't account for the information-theoretic structure of the signal. Gas release generates noise. It doesn't usually generate encoded-looking patterns. Still, the methane hypothesis may end up as the winning explanation if someone can show that a particular geometry of vent, water column, and ridge can produce a channeled, filtered version of gas noise that acquires structure as it propagates. That's the kind of refinement that takes years of modeling, and it's actively being pursued. In the end, the simplest honest statement is that we have a recording. We have a number of candidate explanations. We have specialists with different intuitions, and we have no consensus. That's not the failure of science. It's science mid-process. Public attention demands answers. Science delivers them on its own schedule, which is usually slower than we want. Whatever finally emerges, the episode has already done some useful work. It has reminded researchers that routine monitoring hydrophones scattered across the planet are catching unusual things on a regular basis, and that most of those unusual things never get the focused attention they deserve because no single lab owns the problem of mysterious ocean sounds. Some marine biologists are now arguing for a centralized registry of anomalous underwater recordings, something like a library where unexplained signals can be deposited, cross-compared, and eventually resolved as data accumulates. If such a registry existed, the Faroe Shetland signal might have been paired with a similar event from a different ocean within months, rather than sitting unresolved for years. Whether or not that registry gets built, the larger point stands. The ocean keeps talking. Some of what it says is familiar. Some of it is new. A small percentage of it seems, when measured by the right tools, to carry more structure than anyone expected. What we call those signals and what we choose to investigate will shape what we eventually understand about the noisiest, most complicated, least mapped environment on our own planet. The recording is still there. It hasn't been deleted. It hasn't been explained. It sits in an archive, 14 minutes and 31 seconds of something, waiting for the person or the tool that will finally put a name to the sound. When that name comes, it may be ordinary. It may be remarkable. Either way, the act of listening with real attention is the precondition for finding out. Most mysteries don't resolve because someone had a flash of insight. They resolve because someone refused to look away from a pattern that didn't fit, and kept gathering evidence until the pattern had no room left to hide. That's what's happening here, quietly, in a few labs and a few offices scattered around the North Atlantic. Not a dramatic chase. A patient one. Whatever is down there, or was down there, or passed through once and never returned, will eventually get its name. And when it does, whatever the answer turns out to be, the process of getting there will have taught us something about how to listen to the parts of the world that don't speak human